Thank you, Francis. Well, appreciate you all coming out at noon today. And is it the donuts or just the topic? Or the speaker? I'm not sure which. I'd first of all like to acknowledge my co-authors on this presentation, Wesley Page and Mike Jenkins from Utah State University. For the last 3 or 4 years, I've also been an adjunct at Utah State and have been advising Wesley Page on his PhD thesis project, which deals with fire behavior in mountain pine beetle forests, specifically crown fires, and working as a research collaborator with Mike Jenkins. Certainly a lot of press nowadays about the mountain pine beetle in the western U.S. And Canada. More than 7 million hectares have been affected in the past decade or so. Perhaps there's an even more up-to-date map. Is there one out there on mountain pine beetle? Jen? Yeah, about current enough, I guess. Probably in Alberta, the big issue is the eastern expansion out of the epicenter in BC, and just how far mountain pine beetle is spread eastward is very much in the news. This particular fire occurred in north central BC in 2003 and was viewed as a wake-up call for the impact of mountain pine beetle on lodgepole pine forests. The phrase came out that, my God, it burns like a grass fire. And indeed, it woke BC up at the time. Since that time, a number of modelers have attempted to look at the assessing crown fire potential in mountain pine beetle forests. One of the more notable papers by Simard and others at the University of Wisconsin and Colorado State University, their conclusion was that there really wasn't that much of a threat from the standpoint of crown fire potential in mountain pine beetle attack forests. If there was, it was short-lived. And so when I first saw this, I thought, well, isn't that a nice conclusion? We have nothing to worry about. We don't have a crown fire, or if we do, they're very short-lived. What's the concern? Others have picked up that paper and others that have attempted to model crown fire potential, and in literature reviews, a variety of literature reviews, are kind of repeating the same message. And my way of thinking, that's a very simplistic view, and it really sends the wrong message to both the public, the media, politicians, etc. And perhaps those modelers fixated on the notion that if with crown fires there's a limited opportunity for control until burning conditions improve. And indeed that's the case. But crown fires aren't the only aspect to be worried about in my view. There are many others when it comes to looking at the wildfire potential in mountain pine beetle attack stands. Simply, are there a greater number of occurrences? There's other aspects of fire behavior to be looked at, such as spotting activity, our ability to conduct safe and effective suppression should be paramount. And finally, the recognition that people, be it firefighters or the general public, are part of the fire environment. So just thinking of it in terms of, there's a possibility of crown fires being increased, but it might only last a couple of years. There's nothing to worry about. In fact, there's other things to be concerned about. So the notion of resistance to control and trying to look at it more holistically in terms of the mountain pine beetle situation is the thrust of this particular presentation. Resistance and control is an old term in the fire control vocabulary. It relates to the ability to construct line and the difficulty of doing that, not only in terms of the fire behavior, but the physical characteristics of the fuel complex. Wesley, Mike, and I believe that there's a need to expand that concept with respect to looking at crown fire or just fire potential in general in mountain pine beetle stands. And our notion is that the traditional concerns or assessments of suppression are certainly valid, as well as fire behavior, but there's a need to look at fire safety and look at all these three components in a more holistic way, rather than just modeling crown fire potential or the lack of. So many of the specific details have not been worked out for mountain pine beetle. So in turn, we've drawn upon observations of others, including our own observations, as well as comparable work in other fields. So let's look at fire behavior. A lot of people think of fire behavior, the fire either occurred or it didn't occur, but it's much more complicated than that. Before we do that, we need to bear in mind the different stages of the mountain pine beetle attack in terms of the time since outbreak. The pre-attack stage, of course, a red stage that might last from 1 to 5 years, and a gray stage, perhaps 5 to 15, and a post-epidemic stage, which 15 years beyond. So the three that we'll be talking about is the red, the gray, and the post-epidemic. So fire behavior, it is a number of different characteristics. So it entails whether we can get a fire to start, how fast it'll spread, how much fuel will be consumed, how big will it get, its intensity, the dimensions of the depth, the height, and the flame length, type of fire, be it a low intensity surface or an active crown fire, and also flame front resonance and burnout times. So that moving band of combustion is the flame resonance time over a given point. The burnout time is how long does it take for all fuels to burn out. And finally, other phenomena such as spotting and fire whirls. So fire behavior is a bunch of things. Now, we recently published a note in Environmental Modeling and Software where we have documented that the red needles on lodgepole pine can go as low as 6 to 10%. And we also found that given a fairly wide range in relative humidity and temperature, that we found very little overnight recovery, which was quite a surprise. We thought it would pick up with moisture content would increase with increasing humidities of above 80%. Did not find that. We're still a little perplexed as to why that is, but the reality is another summer of sampling showed the same trends, down to 6 to 10%, normal summertime weather, and so the potential for crowning is certainly a valid concern. In the red stage, because of the lower foliar moisture contents, it's not surprising to see active crown fire spread, fires like the Davis fire, and in turn, prolific spotting out in front of the main head fire. In the gray stage, where we've lost, for the most part, all the attack trees have lost all their foliage. So in these kind of cases, we can still get rather intense surface fires. In that post condition, where a considerable amount of deadened down has taken place from the overstory breaking up, we find that even though we don't see crown fires, we have fires that are still very high intensity and beyond control as well. They would also be out of control in a crowning situation as well. But even in these late stages, with the amount of deadened down, this is one of the, I think the most, when anybody talks about a late stage, they usually bring up the sleeping child fire. So this was in August, not 2001, but in August 1961. So to kind of sum up fire behavior characteristics with time since attack, we've compiled these schematics to show the relative increase relative to the pre-attack condition. So we see a peak in the red stage due to the low foliar moisture contents. As the needles drop, there's a decline, and perhaps we don't see a pickup in fire behavior potential to many years later, when as trees fall over and the spruce or fir increase from the understory, if it's present, then there's a secondary peak. Oh, y'all believe that story? Anybody have any other views about fire behavior or questions at this time? Jen, you must have one, huh?
Well, we were discussing that in the literature, I guess we would say there would be a peak during the red stage for hazard.
Yeah, that's as shown.
So that epidemic is really more like epidemic.
The epidemic is just a little slice here, eh? The red, red stage is there. So there.
Yeah, we were confused about it. We were thinking that epidemic and red, gray.
Yeah. I'll pay you later for that, okay? What about fire suppression operations? How does that play into it? It's always been part of it. Just for those of you that aren't familiar with the concepts of fire suppression science, the aim is to contain the fire by one of the two following means: either removing fuels, either by mechanical means or by backfiring, or we're going to either cool or smother the flames with water, mineral soil, chemical fire retardants, or so forth, either from the ground or the air. So contain the fire from spreading. And then once the fire line is constructed around the fire, we've halted the forward progress, and then begins to prop up the process of mop up and patrol. Okay? So however simple, those are the basic concepts. So John Brewer, would you agree, John Brewer?
I would.
Yep. Basic fire.
Fire triangle.
Yep. So when we look at those three attack stages, each has a unique implications. In the red stage, because we're looking principally at crowning potential, fairly short-lived. Nevertheless, direct attack is probably limited in most cases. So we have to look at indirect means like burning out with using a helitorch. Another factor is that we need wider fire lines than we have had with just a surface fire in a pre-attack stage. In the gray stage, lots of concern about snag falling, either felling snags in the suppression operation or in the containment operation, rather. And also afterwards, probably the most dangerous time is when the snags are coming down. Because there's so much concern with snags, suppression agencies tend to back off, and this allows for the fire to increase in size, increase its perimeter length, and correspondingly become a bigger problem. One fire in Montana last year, 1,000-hectare fire, because it was in the advanced stage here, cost $8 million for a 1,000-hectare fire. And under any circumstances, John, that would be outlandish, right? $8 million for 1,000 hectares? Yeah. But not allowed to put anybody on the ground. Need to use helicopters to do any kind of suppression work. In the post-epidemic stage, with lots of dead and down, not surprisingly, the rate or the ability to construct fire line is slow. The heavy accumulations just lead to much longer burnout times, which provide the opportunity to spot across fire guards. As fuels accumulate following attack, we looked at a number of models for production rates, and we found that they all decrease as the fuel load or resistance to fuel resistance class increased. So they all, not surprisingly, slowed down the production rates. So suppression. From a suppression standpoint, we very quickly rise from the pre-attack stage, and concerns about fire suppression operations just stay elevated. You notice in this graph and the previous graph, there's a question mark beyond about 40 years. To our knowledge, nobody's done any sampling in stands that are older than 40 years old since attack. There's been some simulations, but no actual field work. So that's why we put this question mark out there. Perhaps it goes up, or we've conservatively had it decreasing. Firefighter safety, another what we believe needs to be added to resistance control. These are the 4 natural hazards that affect firefighters: being burned over and trapped by a fire, or conversely, a snag or a fire-weakened tree falling on you, rolling rocks or logs on steep slopes, and lightning. You can also be seriously injured or killed by the suppression operation itself. You can get hit with a helicopter blade. You can, on your way to the fire, you can roll the truck and kill yourself. You can get injured through the aerial firing operations. So to date, we're not aware that either a firefighter or a member of the public has been killed by a fire in mountain pine beetle, but there has been at least one documented close call on the salt fire in August of 2011. Bulldozer operator and his driver were burnt over. There's some footage on YouTube of the salt fire. Just key in salt fire and you'll see the video taken on one of the burning days. In that red stage, with the likelihood of crowning being increased due to the low moisture content in the red needles, with the onset of crowning, either in terms of the fire spread rate or its intensity, this onset of crowning represents quite a dramatic increase and change in those two properties. So as a result, firefighters can be caught off guard, as they were in British Columbia in 2003 on that earlier fire in the north central region. This increase in rate of spread can correspondingly decrease the time for firefighters to travel along their escape routes and reach a safety zone, if they're not expecting this sudden change or predict it or forecast it. In the gray stage, with a lot more dead and down fuel, the size or the opening for the safety zone to ride out an entrapment correspondingly increases, because not only do we have high flames potentially, but they last longer because of that accumulation of dead and down materials. In the gray and post-epidemic stages, concerns about falling trees or falling stags are a real concern. There are any number of incidents. Two examples here showed with felling snags in the United States that led to deaths of firefighters. And this issue of falling trees or snags, it's interesting to look at other insect or disease affected forests, such as in the sudden death oak type, where could be relatively mild fire behavior, but the real concern are the large trees that are falling. When we get to the post-epidemic stage, these large accumulations of principally coarse woody debris. This is the forest type that the 1961 Sleeping Child fire burnt in. So a lot of jackstraw timber with some young reproduction coming up through. Trying to move from the fire area to your safety zone along out of the fire area in general would constitute quite a challenge, unless you have pre-constructed escape routes, which means you got to saw your way through to create those. That takes time, and at the same time, if the winds are high, there's also a hazard of just snagfall in general. So, from a safety standpoint, we've speculated that the greatest hazard is going to occur in the gray stage, and again, we're uncertain what happens, beyond 40 years. So, what are some of the implications for fire research and management as a result of thinking about firefighter safety, the fire suppression operations, and fire behavior? Well, we've looked at these three aspects, and each has a corresponding peak, not necessarily during the same attack stage, which goes to support our notion that you can't just look at mountain pine beetle in terms of whether it's got the potential to crown easily or not. There are other issues just as equally as serious as crowning potential. So we feel like we need to broaden the traditional concept of resistance to control to also incorporate firefighter safety into the mix. This for some modelers, this may not be terribly satisfying because there are models, readily available software to produce simulations of fire behavior. Trying to model suppression operations and firefighter safety, not so easily done. So for a lot of modelers, it's like, well, gee, I can't get my papers produced quick enough because those models aren't out there. Well, tough. Go out there and start working on some of the basics. So here's our, at least conceptual, quote, model for wildfire resistance to control. And each of the three components, there are a number of aspects to be examined. So it's not just whether crown fires are possible or not. There are other issues to be considered. Work that's currently going on across Canada or the United States to address some of the major knowledge gaps, and there are many. Just a recent fire in north central BC at Carrot Lake, an experimental study area. And in this particular fire late in August of this year, the stand had been attacked in 2003, I believe, and so the project personnel decided to accelerate the dead and down by going in and chainsawing over 50% of the basal area to try to. They'd lost the needles and they couldn't wait for another 10 years to see what kind of activity. So this is with 50% of the basal area removed. So there is some work, but in our view, there's a long list of a long laundry list of things that need to be worked on, and I won't go through these, but they touch on all three components. So the details of this presentation are going to be published in the Forestry Chronicle in the November-December issue in a month or so's time. And I want to thank you for your attention and would entertain any questions. Also interested in your comments as to thinking about fire behavior or fire and mountain pine beetle stands in this context, which is a lot more holistic view than has been taken in the past. So, thank you.